Now, sometimes you're going to have to go backwards from the sigma notation and then actually write the integral. And so what I would encourage you to pay attention to, there are two things that are super important. Well, there's actually more than two things. Let's just start with one. I would first look for my delta x. And so I can see that here in the 5 over n, the 5 over n. That's going to be my delta x term. I can see where I have an x by looking for an index like I or k. That means that's where I have an x. So wherever you see that variable, you would have an x in your integral. The other term that's going to be important is this value right here, and that's going to be your a. So remember, our formula was limit as n approaches infinity of the sum from k equals 1 to n of f of a plus delta x times k times delta x. Now they're using i's in this problem, but you'll see it with various variables. I, j, k are the most common ones. So when I'm going to write my integral here, I'm recognizing that my delta x is 5 over n. And that also means that my b minus a is 5. So the width of my interval is 5. So when I'm writing my integral, I'm going to start at negative 2. My width is 5, so that means I'm going to add 5 to negative 2, which means I will go to 3. Okay, so that's the information my delta x gives me. Now I'm paying attention to my function. My function here is just x. This whole part is going to be my x. The I tells me that this part is going to be my x, but remember it's a plus delta x times k that's replacing your x. So that is just going to, my function is going to be x squared minus 3. This delta x on the outside gets replaced by a dx. So my integral is just negative 2 to 3 of x squared minus 3 dx. Now this was a simpler case. Sometimes they are going to be a little bit more complex. But usually if it just wants one integral, you can write it this simply. In the next one, again, my delta x is 5 over n. So I recognize my delta x, 5 over n, 5 over n. I see my I right there. So I know that this part is going to be my x. And my a is going to be 1. So my integral will start at 1. Since my delta x is 5 over n, that means the width of my interval is 5. So I'm going to add 5 here. So I'm going to go from 1 to 6. And then my function. This whole part is my x. So my function is 3x minus 4 dx. Pause the video now and see if you can try the next two on your own. Okay, let's try this one out. So I see 6 over n for my delta x. That means my b minus a is 6. So I'm going to start at negative 2. That's my a. Plus 6 is 4. My function then, this is all my x. So x cubed. And then just times dx. Last one. We have square root of negative 2 plus 2i over n squared plus 1 times 2 over n. So there's a lot going on there, but let's try to break it down. Again, I'm going to start at negative 2. My delta x is 2 over n, so the width of my interval is 2. So I'm going to add 2 to it. So this will be negative 2 to 0. My function then is, I see the square root. Remember, this whole part is my x. X squared plus 1 times dx. Now, where these problems can get a little tricky is when we have multiple options that could be right. So different functions and their integrals will have the same integral values, and so there's more than one integral that could be represented by this limit value. And so what we want to do is try to figure out which of these could actually be the integral. And so if I just set it up the way we just did, I see that my delta x is 5 over n. And so the width of my interval would be 5. And then I start at -1, so I'd have the integral from -1 add 5, that gives me 4, sine of x dx. So this first one definitely works. But don't automatically assume that the other ones don't work just because the first one does. Let's try to see, and I think what's actually easiest, instead of trying to make this one match the other one, see if we can write this integral in our limit form. So we would say limit as n approaches infinity of the sum from k equals 1 to n sine of -1 plus our x, we'll have to come back to that x, times our delta x. So our delta x is still 5 over n. And then we have 5k over n in place of our x. Or sorry, technically I'd have 0 plus 5k over n there, but that is the same thing as 5k over n. I'm going to rewrite that a little nicer there for you. And so does this match up with the limit that we have here? It actually does. So that one works as well. So at this point, I should be able to tell that my answer is D, 1, 2, and 3. Don't do too much work if you don't have to. I see that 1 and 2 both work, so 3 will work as well. Since we're doing it together, though, let's actually go ahead and calculate this. Now pay attention to the 5 out front. 5 times. Now we'll do our limit notation. Limit as n approaches infinity. The sum from k equals 1 to infinity. Sine of -1 plus 5 times x, okay, times our delta x. Our delta x in this case is just 1 over n. 0 to 1 is 1. And so inside here, we'll have 5 times, we started at 0, 0 plus 1k over n. Now at first glance, this doesn't look exactly the same, but maybe with a little manipulation we can change it. So this 5 right here, I can actually bring inside my limit. I can multiply that by 1 over n and get 5 over n. We'll come back to this middle stuff in a second. So that could be 5 over n. And then this part here, 5 times 0 plus 1k over n. Well, the 0 cancels out, so I'm just doing 5 times 1k over n is 5k over n. So this one also works. It wouldn't be the most obvious way to go from this limit to the integral, but the integral does actually work here. So make sure you're checking all of your options.